Thanks, Max. Yes, tools for unstructured grid models. If you're wondering what an unstructured grid model is, it's like over here on the right, there's a picture of one of these meshes, and you can make them have big elements offshore and really, really tiny ones inshore. So they're really popular for representing the complicated coastline geometry and bathymetry. And there's a bunch of these different models. And you can imagine, like if you're on some element here, like you have lat long at the nodes. If you want to know where this element is, you have to know which nodes make up the element. And so, each of these models, of course, does it in their own way with their own variable name. So there's some variable with nodes with one dimension and three in the other dimension, or maybe three by node, and it may start counting at one, or it may start counting at zero, and it may have a name of mesh topology, or it may have a name of something else. And so to deal with all this, the community about 10 years ago, after 20 years ago, we realized there's a problem. 10 years ago, came up with the U-grid conventions. And 5 years ago, Deltares came up with this XUgrid Python package that supports the U-grid conventions. So the U-grid, of course, is just like CF conventions, a bunch of attributes which disambiguate all that stuff so that you can write software packages like XUgrid that then just work with any of those models. So I'm going to shift gears here and go to my notebook. And so just as a review of pre-Pangeo times, this is like how we used to do things. So we'd like import FS spec maybe, and then list some, netcdf files sitting off on open data. In this case, they're netcdf3 files. You find out the hard way when you try to open one up with like, as FS open. So you download a file and you wait 15 minutes because it's 100 gigabytes. And then you open it up in Xarray and take a look. And you find this, okay, you got this thing that's got some time steps and some layers and a bunch of nodes. This is the temperature variable. And then if you want to plot this thing, there's a tri-mesh routine in GeoViews and Holoviz, but you have to do some crazy crap in here. You have to like take your latitudes and longitudes and put them into a data frame, and then you got to do some projection, and then you got to make some other data frame, and then finally you get to do your GeoViews tri-mesh. That's no fun. So you can write oops, let's import just to show this works though, let's import these packages. You got to import a whole bunch of stuff. And, if you do all that, you can like pick a variable and a time step and a level and eventually you get your, you get your plot. Okay. But there's a better way to do things. And that better way is, there's one more slide. And this is, okay, so you got all these models, you got your U-grid conventions, you got your XU-grid, and then I vibe coded this little hvplot.xugrid thing a few months ago, and it's sitting in a pull request. They're not sure what to do with it. Part of the motivation for this talk is, if people like it, they can upvote it or something. So this is the way it works now. You go do your virtually czar, references for all those netcdf files, and you create your ice chunk, and then you create your stack catalog items. So here we import PyStack, and then we go like load our item, and we get the ice chunk asset, and then we open that up in Xarray and take a look at the variable. And this opens up pretty quickly. And once we get our variable, in this case, we can see that this thing is 2.7 terabytes, but the chunks are the same. And so then we can just go now import this thing, because I put the U-grid convention attribute stuff into the ice chunk, because that's super easy to do too. Then you can just import it and get this XU-grid object, import hvplot U-grid, and then just use your nice little hvplot tri-mesh. And then this looks a lot more like, what we're used to, and there we go. And just to show you that this actually works, we can, zoom into some region like, Massachusetts Bay, and we get the re-rasterization and the full, mesh. So that's it. U-grid, XU-grid, and my pull request for hvplot XU-grid. Thank you.